Hello everyone, welcome back to my channel. In this video, we are gonna look at how to set up an Apache web server using Terraform provisioners. So in our previous video, we looked at how to use SSH keygen as our key pair for our EC2 instance. So this is the code that we got. Everything else remains the same. We have our backend in the S3 bucket. We have these variables, and the provider is of course AWS in our specified region. In this tutorial, I'm going to create a shell script, and then we will use Terraform provisioners to run this shell script when the instance is booting to set up automatically an Apache web server that we can access on our web browser. So I'm going to create a file. Let me use touch, and the file I will call it icons.sh or shell script. So this is my file. And of course, it's a shell script, so we need our interpreter bin bash. So first, of course, our instance is Amazon Linux, so we're using yum. So first, you update all packages. Because we are automating everything, that's why I'm adding the flag -y, because whenever you are doing an update or installation, you get prompts where you have to enter yes or no and stuff. So this will automate yes for all those prompts, okay, for this particular update. And I'm using sudo so that in case a user is not set up, it doesn't stop it from installing everything. Alright. Next, I will do some installations. Yum install, and I'm going to install wget or install it on zip and Apache web server. And I'll also give it the Y prompt. Okay, yes to all prompt. Start the Apache web server. Enable the Apache web server. All this is going to do is to ensure that Apache starts working on the boot of the system. Okay. Now, Apache requires that there's a flow of traffic that's allowed via HTTP. Okay. So I'm going to do some firewall settings. Okay. This is going to allow for traffic through HTTP. Then we do a reload of it just to be sure that everything works. And now I'll use wget. Wget is for downloading stuff from the internet. Okay. I'll use that to download a web browser on the internet. I'm using twoplate.com. Now this is a website that has so many templates of HTML and CSS web browsers. Okay, so there's a lot of them to choose from here. So for now, I'm gonna pick this one, clean work website, and then I'll click download to download it. Okay, now you see that when it finishes the download, this is a zip file. Since it's a zip file, we need to unzip it, and that's why we needed the unzip program right here. So wget is gonna download our web app from the site we went to, twoplate.com, and because it's web app is zipped from the browser when you download it, we are using zip templates, and then the name of the download is 2132_clean_work, right? So 2132_clean_work, and it's a zip file, so .zip. By the way, I already downloaded it earlier, so that's why you see the parenthesis 1. So I'm using the original. That's why I didn't put the parenthesis 1 there. So after we download it, of course, we now need to unzip it. So the unzipping is 2132. Next, we need to copy it into the destination of web browser for Apache Web Server. Apache Web Server, unless you change it, looks for the web app in this directory. So we need to copy everything that we have from the web app after unzipping it to this location. So we copy. There may be folders in there, so copy recursively the content of this. So everything inside of this directory, we are copying it inside this var www.html directory. And then after that, of course, it's always best to restart your Apache web server. So this is a very simple shell script that will run after our EC2 instance is booted. Now let's go back to the resources. I'm still using the key pair that we created using the SSH keygen in our previous episode. And then, so I need this shell script to run whilst this EC2 instance is being created. Okay. So within this resource, I will provide some provisioners. The first one, I will use a provisioner file. So there are three main provisioners. We have file, we have remote-exec, which we use to remotely execute a file on a server, and then we have local-exec. Local-exec is for, of course, like the name goes, executing a file locally. So for file, we need to specify the source. We need to specify the destination, which is the remote server. Okay, we will do that. Now our file is our iquant.sh. So we have iquant.sh, and then the destination on our remote server, I'll keep the file in the temp directory as the same file name, iquant.sh. Okay, so this will transfer this file into the AWS EC2 instance. Good. Next, by the way, this should be provisioner, not provisioners. The next provisioner, we are not just sending a file, but we need to execute this file as well at the same time. So we need remote-exec as our next provisioner. And for that, we can use the inline command where we specify the commands to run as a list separated up by commas. Okay, so first, we need to make sure that the iquant.sh, the shell script, has execute privileges. Okay, so first I'm going to change the execution. You can do u plus x to make it executable. By the way, we are running it from this location once it's on the server, so you can't just use iquant.sh. You have to make it temp/iquant.sh. You can do it this way, or you can use the numbers like 777. Either one is still fine. And then after making this shell script executable, you need to now run it. So run it, have tmp iquant.sh. This is a shell script, right? To run a shell script, you need to specify the shell script interpreter. But in our shell script, we already specified it here as a bin bash, so we don't need to specify it here anymore. So just by typing the file name and showing the location where it is, pressing enter, this will run as it stands. Alright, so that is for remote execute. Now imagine we are remotely executing a shell script on a server, right? If you look at our code here, we are creating the server, transferring the file to the server, and remotely executing to it. No part of this have you talked about how we actually establish a connection between Terraform and this remote server to run these commands. Okay, you know that if you are doing it manually, we would take the IP address, connect to it via SSH, and then run these commands on the terminal. That's how you would do it manually. So if you are automating it, you have to also establish a connection. Okay, and of course that connection is going to be via SSH. So type SSH need to specify the user. The user is var.user in the variables file. It's just like logging into a EC2 instance. SSH-I, specify the key pair, the user name at the IP address. Okay, same way. SSH, this is the user. You need to specify the key pair. We can use our private key, private underscore key. Remember, our private key is this right here. So we will use the file provisioner to specify iquant keys as our private key. Okay, and then we need the IP address. The IP address will be the host, and to specify the IP address, we call it the solve.public underscore IP. So this means the server that you are creating, which is self, and then you pick up the public IP. This is similar to how you pick up public IP in the output for the EC2 instance. Okay, very similar. Okay, save this. Looks like everything looks good so far. By the way, if you miss anything, I'll upload this code into our GitHub repo, so you can look at the link in the comment section below to access the GitHub repo if you miss anything. Let's initialize Terraform. Okay, format it, then let's do a validation. Okay, every code we've entered is valid. Now we can do Terraform plan. So 2 resources to add. So it's still the EC2 instance and the key pair. And now Terraform applied. I'm gonna pull this up a bit so that you see the whole installation going on. Yes. By the way, this is the public key. This is the full content of the public key. Yes. Okay, so you can see remote-exec executing the shell script, and it's connected via SSH. So you can see here, it was connecting. I think we have an error somewhere. Oh, so I made an error here. It should be HTTPD. It's Apache, I forgot the D. This is HTTP traffic, so that is fine. And this should also be HTTPD. So we have to apply Terraform again. By the way, in this case, the 2 resources were created. Okay, EC2 and the key pairs were created from scratch, right? So what Terraform apply again is going to do is it will first destroy everything that is created already and then recreate it. It's completed destruction and it's now creating. Alright, so you can see that apply is complete. We have our IP address here. So I'm going to copy that IP address, go to my browser, paste it here, and then :80. Apache web server uses the port 80. Okay, so press enter. Now this cannot be reached because our instance that is created right here. Check the inbound rules. Yeah, so only port 22 is allowed on this instance, so we need to add port 80 for Apache. So I'm gonna add port 80 from our IP, and this is for Apache web server. This is for SSH. Save rules. Okay, now if you stop this and then paste the IP port 80, voila. Okay, so you can see that our website is running perfectly, and we did everything from the terminal using Terraform. Okay, If you click on it, everything works. Right. One more thing before we go. You realize that I had to just allow port 80 for the inbound traffic, okay, for this web browser to be effective. Now, how can we also automate this? So far, we've automated most things up to key pair, okay. We can also automate the creation of a security group. And so that's going to be the next session that we look at, where we create a VPC and automate everything, and we can create inbound and outbound rules inside of our VPC, or virtual private cloud. Okay, so that's going to be one of the upcoming tutorials under Terraform. So please be on the lookout for that. Again, thank you for joining me. Like this video, subscribe to my channel, and see you in the next one.